In these examples, we've got two right-angled triangles. In each of those right-angled triangles, we can apply Pythagoras' theorem, but only if we know 2 out of the 3 sides. In this first example on the left-hand side, we've been asked to find the value of x. Now, if we look at the triangle which involves x, the right-angled triangle which involves x, we're looking at this triangle here. Now, the problem with finding x at this point is we know the length of the base side, 4. The height is y, we don't know that. And the longest side, the hypotenuse, is x, and we don't know that either. So at the moment, we only know 1 out of the 3 sides. So let's take a look at the other triangle. The other right-angled triangle here is this one here. And in this triangle, we know the length of the hypotenuse, 6. We know the length of one of the shorter sides, 3. And we don't know y. So we can use this triangle, first of all, to help us take the first step towards finding x. The first thing to do here, to simplify things, is to draw the triangles out separately. And you can see we've done that here. The triangle highlighted in green is this triangle here. The other triangle, which I'll highlight in red, which we'll use in a minute, is this triangle here. By drawing them out separately, we separate the problems and we can see exactly what we need to work out. So we'll now use Pythagoras' theorem to find the missing side, which is y, of this first triangle. We'll do it in silence and then explain. So let's explain what we've done. Firstly, we labelled the sides. We knew that this side was y, but as one of the shorter sides, we called it a, and the other shorter side we called b. The longest side, the hypotenuse, we labelled c. We then stated Pythagoras' theorem, and we should do this at the start of each example. A squared add b squared equals c squared. We then substitute in the values. A is our unknown, which we know as y. B is 3, and C is 6. These two numbers that are being squared, we can work out. This one's 9, and this one's 36. But we want y on its own. The first step is to get y squared on its own. So, you can see here we've shown our workings. We're going to subtract the 9 from both sides. And that gives us that y squared equals 28. Now, the inverse of squared is square root. The positive square root, which is what we're interested in because it's a length, is that y equals the square root of 27. And you'll see in a minute why it's worth us keeping it as a surd, as in a square root of 27. We'll now go on and give ourselves some space here. I'm going to draw a line that very clearly denotes the difference between those two working spaces. We're going to have a look at this second right-angle triangle. We know that this length here is now the square root of 27. We worked that out a moment ago. Let's see what we can do with Pythagoras' theorem to work out the value of x. Again, we'll first do this in silence and then we'll explain. So let's explain what we've done. Firstly, we did the same thing again. We drew the triangle out. We labelled the two shorter sides, A and B. And we also labelled the longer side, the hypotenuse, C, which is also known as X. We first stated Pythagoras Theorem again, and it's good practice to do that at the start of each example. A is 4, B is the square root of 27, and X is the value we're trying to find, the length of the hypotenuse. 4 squared is 16. The square root of 27 squared. Now, 27, square root and squared are inverse operations. So the answer there is 27. And you can see here why it was worth us not working out an approximate answer to the square root of 27 at the halfway point. And they're equal to x squared. That is to say, 43 is equal to x squared. And the positive square root of x gives us x equals the square root of 43. And that's our answer. If we want to put that into a calculator and apply an approximate answer as a decimal, that's absolutely fine, but the exact answer here is the square root of 43. I'd like you to pause the video now, and I'd like you to try to explain your answer and copy down the workings just as they are. There's 2 prompt questions in the middle which may help you. Once you've done that, have a go at the question on the right-hand side. Pause the video now and play the video on when you're ready to go through the question on the right-hand side. So, we'll go through the question on the right-hand side. The first thing to note is that we need to draw our individual triangles. You can see here the top triangle is the triangle on the right and the bottom triangle is the triangle on the left. We've drawn them in that order because we can see that this triangle here, which is the top one of the 2 triangles below, is a triangle which we know 2 out of the 3 sides, and it's important to start with the triangle which we know 2 out of the 3 side lengths. And then the other one, we will know 2 out of the 3 sides once we've worked out the length of y. So let's start by looking at this first triangle. We start out by labelling the sides. The hypotenuse is C, this shorter side is B, and we'll call this side that we're looking for, which is also going to be called y, we'll call it A. Let's state Pythagoras' theorem. A squared add B squared equals C squared. We'll then substitute in the values. A, we're calling y here. B, well, B is 3, and C is 7. Let's work out some of those values. Y squared plus 9 equals 49. Hopefully you can see we can solve this. We need to solve this by, well, at the moment, y squared has got 9 added to it. So we're going to subtract 9 from both sides. And that gives us y squared equals 40, or indeed y equals the square root of 40. And you can see that we've already written that down here because that's our length that we know, that height of that triangle. So the work has been done on the first triangle. We'll draw a line to note the difference between the 2 calculations. Now we're looking at the second triangle. We'll label the sides. We'll call this side A, this side B, because they're the 2 shorter sides, and the hypotenuse is C. We'll again state Pythagoras' theorem. A squared add B squared equals C squared. Now let's substitute in some values. A is 4 squared. B is the square root of 40, and that's going to be squared as well. And C, well, that's our length x that we're trying to find. Simplifying this, 4 squared is 16. The square root of 40 squared is 40, and that's going to be x squared. And what have we got here? We've got 56 is equal to x squared, and that means we want the positive square root of that, so x is equal to the square root of 56. And that's a length of x.